This is the walkthrough for Unit 7, Assignment 3. You have the function v of t equals capital A times, open brackets, 1 minus e to the power of minus t over capital T, where t is the maximum speed in seconds. T is the variable of the function, is time in seconds, and t is the maximum speed as we said before. We want to find, to identify the units of the coefficient A, the physical meaning of A, the velocity of the car when t is equal to 0, and the asymptote of the function as t goes to infinity. Right, we start the first one. Let's write the formula of the velocity function. Okay. This is meter per second. So this function represents a velocity and the measurement is meter per second. If we do t over t dimensional analysis, that's going to be seconds over seconds. So this is going to be dimensionless. This ratio is going to be dimensionless. And then e to the minus something, a constant, is dimensionless. Of course, 1 is dimensionless. E to the minus t over tau, capital T, is dimensionless. So the 1 minus e to the minus t over capital T is dimensionless. Okay, so the constant A should have unit meter per second. So when you have v of t equals A times 1 minus e to the minus small t over capital T in meter per second, A is going to have units meter per second. So the units of the coefficient A are meters per second. Now we check what is the physical meaning. If you take the limit as t goes to infinity, so as t grows to infinity, if you take the limit of this, of the function v of t, then you have the limit of t going to infinity of A times 1 minus e to the power of minus small t over capital T. So the limit as t goes to infinity of this term goes to 0. So you have limit of t goes to infinity of A times a limit of t goes to infinity of 1 minus e to the minus t over capital T. This will go to 0. So let's make a small remark here. When t goes to infinity, e minus t over capital T is e to the minus infinity. This will go to 0. And you just have the limit of 1, which will go to 1. And the limit of a constant is going to be A. And the limit of t goes to infinity of 1, that is going to be 1. So the final answer is going to be A. What this means, that is as the time grows, then A will be the final velocity. As t goes to infinity, then the velocity of the vehicle is going to stabilize to this A. That is the physical meaning. from the final value theorem, A is going to be the final velocity as t goes to infinity, as time grows large enough. Now the velocity for t equals 0, it's just a substitution. We have v0 equals a times 1 minus e to the power of minus 0 over capital T. E to the power of 0 is going to be 1. So we have a times 1 minus 1, a times 0, so that's going to be 0. The velocity for t equals 0 is 0 meter per second. Now the asymptote of the function as t goes to infinity is the following. Is going to be a line parallel to the time axis, so it's going to be of the form g of t equals a constant. Take the limit of the function v of t as t goes to infinity to find the asymptote. That's going to be the limit as t goes to infinity a times brackets 1 minus e to the minus small t over capital T. That's going to be basically what we did before. Limit as t goes to infinity of a times limit as t goes to infinity of 1 minus e to the minus small t over capital T. That's gonna be a. Then limit of the exponentially decaying function is going to be 0, and the limit of 1 as t goes to infinity is 1. So the function g of t equals a is a horizontal asymptote. Of the function v of t as t goes to infinity.